Good evening, Professor. My name is Kazi Ahmed, and my ID is N1546059 And tonight, I plan on doing I'm gonna do the final presentation for my case study, my final project, the B2 System Engineering case study. And here I'm gonna start with a little bit of background because I feel, before I move on to the uh, developmental engineering development phase and the challenge, the risk, it's important that I talk about the need analysis, the concept, the overall system design, and then I move on to that part. So I'm going to give a bit of background so you're kind of up to date, in touch with what's happening, and then I go on to the next phase. And yes, so this is going to be the presentation, and today is the 10th, and I'm doing the presentation right now. Just wanted to get it done right away. I've my final report, it's done. Just going over some final citation and some formatting, and it should be done pretty soon. I hope I'm not gonna bore you with the presentation, so I hope it's gonna be concise and within that 30 minutes phase. So I'll get to it right away. So, like I said, the name is already there. It's gonna be the B2 case study final presentation for my course Intro to Systems Engineering. The first, excuse me, I'm gonna give you the table of contents of how I plan on going at the presentation, how I'm plan on doing it, and the steps I'm gonna take. So the first, I'm gonna give the intro, and then the background, then the need analysis, and the concept, the system design, the engineering developmental stage, the post-developmental stage, the challenge and risk, and the summary and lesson learned. So first, the intro, just to give an overview of what I've already mentioned. So the B2, mentioned as in the midterm presentation. So the B2 Spirit, also known as stealth bomber, is an American heavy strategic bomber featuring low observable stealth technology, which is at the forefront of this the B2 stealth aircraft. It's designed for penetrating dense anti-aircraft defenses. This is how it looks like, and then to give it a bit more intro, so the stealth is one of the key factors required for establishing air superiority in modern warfare, which this is based on. The bomber can deploy both conventional and thermonuclear weapons, such as up to 8,500 pounds class, designed and manufactured by Northrop, later Northrop Grumman. The cost of each aircraft is averaged at $737 million in 1997 dollars. So the B2 is the only U.S. aircraft that combines long-range stealth, low observability, all in a single platform aircraft, giving it the ability to project and utilize the power anywhere in the world under any given conditions. So what is the stealth technology? So it's known as the low observability. Used in military aviation, it reduces detection range of an aircraft, and it's partial invisible to radar and other detection systems, and it's similar to camouflage tactics used by soldier, where you kind of hide in your enemy area. So so there are approximately 80 pilots currently that fly the B2. Each aircraft has a crew of two, the pilot in the left seat, the mission commander on the right. And the B2 is highly automated, and one crew member can sleep in a camp bed, use a toilet, or prepare a hot meal, or have a dinner, take a rest, take a nap, while the other pilot in this case can monitor the aircraft, unlike most where you need two pilots to actively be working at the same time. So background. So by the mid-1970s, military aircraft designers had learned of a new method to avoid missiles and air interceptors known today as stealth. The concept came with the idea to build an aircraft with an airframe that either detected or absorbed radar signals in a way that almost no messages or signals were sent back to the radar unit for detection, in this case the enemy. So the B2 originally came into existence to profit from the advances in stealth research that grew out of laboratory experiments, researchers all the way back to 1970 to 1976, within that 6 years period. Stealth offered a new and revolutionary approach for penetrating the sudden growth of Soviet defense system of highly sophisticated radar detection networks. So in this case, what's important is that the kind of growth of Soviet air warfare. It's one of the fundamental reasons why B-2 was invented in the first place. So the fighter was the first type of weapon that, in the study of the benefits of stealth, is automatically the next promise. The early researchers show great promises. Northrop Grumman and Lockheed were competitors, and in the end, Northrop won the contract to create and take control of for the further researchers. The first flight of the B-2 was actually on 17th of July 1989, with the first operational mission of the aircraft. It happened in the Balkan conflict in the December 1985. So the need analysis. So as you can see, that's a picture. That's the B-2 aircraft taken from an aircraft above. So the B-2, the DoD had already developed a mission area for this strategic nuclear strikes, and allocated bombers to SAC, or known as Strategic Air Command, and made stealth technologies an operational strategy. So the government requested the industry to assess possible solutions for the missiles, so the contractors share this responsibility. Not one company or organization would be in charge of the entire thing. Both the government and contract personnel work hand in hand on the same team to derive the lower level requirements and to assess the effect of trade-offs and the original actual top level objectives and final goals. So the concept exploration, I'm going to briefly go over these because I want to move on to the engineering development phase. So the first, from the very beginning concept, the responsibility was of the requirement at the operational and the overall system architecture was an objective divided equally with the contract and government. So the government specified a broad set of essential performance objectives, and the competing contractors wanted to take charge of it, were funded to pursue solutions and further allocate the technical requirements in that ever-increasing level of detail and specificity. So that's a diagram where you have the need analysis leading to concept exploration, and where any kind of requirements will alter either of these, such as the concept, and concept moving forward. And also need analysis uses system studies to move on to concept exploration. The process unfolded continually during concept exploration and eventually converged to a contract specification. So the concept exploration period for the B-2 started when the Advanced Strategic Penetrating Aircraft (ASPS) studies were taking place. Engineers and scientists investigated various techniques to avoid detection, dating all the way back to 1940s. By the mid-1960s, the Air Force Avionics Laboratory at Wright-Patterson Air Force Base had funded studies to develop radar cross-section prediction, computer programs, camouflage techniques, models, materials, and concepts. Northrop successfully developed a RCS, a radar cross-section prediction code called GEMS-CAT, and had successfully predicted the radar cross-section of an available F-4 fighter jet. So, this part is kind of important, where it talks about how it's kind of what's used initially. So it was a 1973 Yom Kippur War that forced the need of bringing stealth technology to the forefront and manufacture this as an operating system. The sudden vulnerability of being attacked by the Soviet air missiles and radar technologies kind of showed new and more sophisticated technology was mandatory to combat such attacks, hence stealth was the obvious choice. So Northrop and McDonnell Douglas received contracts for this work. So Lockheed came into the scene after some time. So the conception of the Northrop B-2 stealth bomber was funded by Air Force in 1980. It was during the study phase that the fundamental architecture of the B-2 avionics was derived. The dominant architectural decisions were in the areas of radar, navigation, cruise station, computer software, and data bus. This is system design. So this is a more of a system design surface description of the B-2 system. So you have the stealth at the forefront. The surface is made from radar absorbent materials. Saw two drilling edges aligned at one of the two angles dome. Incoming radar energy away from the aircraft. That's the crew area. The engines are set up right there. For General Electronics, turbine engines produce something like 34,000 kilograms of thrust, and that's the exhaust. and that's the flight control is right there, and the weapon that are in-flight weapon. So 2 weapons based within fuselage each carry 8 D-61 free-fall nuclear bombs or 8 SRAM-2 nuclear missiles. Cells. So the system design. So the B-2 system the weapon system consists of the B-2 aircraft and onboard system that has a cockpit, which accommodates 2 crew. So the cockpit is equipped with color 9 tube electronic flight instrumentation, which displays flight, engine, and sensor data. And the B-2 aircraft is a multi-role bomber capable of conventional and also traditional munition, as well as nuclear weapons that I just mentioned in the slide before. It's still the low observable characteristic give it the kind of give this the ability to penetrate in areas that are highly sophisticated and have targets that are protected with the high extra security. So this is a picture of the top and the bottom, the front and the bottom. So the figure shows the top, bottom, and the side view of the B-2 aircraft, as well as the control surfaces, the access doors, and other architectural designs. This is also included in the final report of the paper, so it's for better understanding of the overall system. And this this diagram kind of shows all the companies responsible for designing all the different parts of the surface, all the different parts of the B-2 system, such as yellow indicating Northrop, blues indicating Boeing, the orange indicating Vought, and the green indicating GE, and the red as Hughes. So the next stage. So this is the part that's gonna elaborate a lot more of the detail of the system. So I'm gonna talk about the engineering developmental stage, the system engineering challenge, and then I'm gonna go to the post-developmental stage, the systems engineering challenges of the overall program, and the summary and lesson that I've learned, that I've taken from this case study, and what I've learned from this the class itself, and how I can incorporate that with the lessons that I've learned in this case study, and how these two can kind of coexist together, and how the course has kind of helped me to kind of identify certain problems that I found in the B2 case study and what I take from that. So the first is the engineering development phase. So it's important to understand the whole existence and the actual functionality of the point of the B2 system is dependent on the stealth, or its radar evading quality. Just to use a different word. So the basic concept of low observable, it lies in the reduction of the RCS, which is mentioned before, which is also given by Northrop, and it's called GEMSCAD. It's just a code. It's a reduction of the RCS, right? So the radar cross-section is a measure of the power scattered from the target to a particular direction at the moment when the goal is charged up by electromagnetic radiation. So what is electromagnetic radiation? I just want to give an overview, kind of like a very simple definition. So electromagnetic radiation is is energy that is propagated through free space through a material medium in form of electromagnetic waves. I felt like this was important before I move on to the next stage. I just wanted to briefly discuss electromagnetic radiation. So a larger RCS means an object is more frequently detected with the enemy's radar system. In this case, which is the one thing that we don't want. They want to minimize it as much as possible. So the larger objective is to minimize RCS as much as possible, and in doing so, making the B2 a low observable or stealth system. So how to reduce the RCS? So there are four different ways on how to go about it, and they have been given names, or the technology, 4 different steps. They're shaping, using radar absorbing materials, active cancellation, and passive cancellation. So these are the 4 steps on how to reduce the RCS, and by doing so, making the B2 low observable. So I've looked at this part of the engineering development stage because I felt this was the key part in getting the whole B2 system to getting the whole B2 system to work, to function, and to kind of do what it's required to do, what it's meant to do. So I've kind of focused on this part which is the stealth part. So also by when I mean the RCS, by minimizing RCS, you're getting it low observable. In other words, you're making the B2 system stealth, which is what it's meant to do. So I feel like this was the key important engineering stage in the development stage. So the shaping, excuse me. So this